12.2 Graphing Systems of Linear Inequalities. Before we start with the lesson, let's go over some vocabulary. The type of inequality that we're looking at here is a less than. And if you notice, the bar at the bottom, the equal part, is not there. So since that is not equal, we're going to draw a line, but that line is going to be dotted. That means that any point on the line will not count. And then when you shade, you're going to shade either to the left if your line is vertical, or down if your line is horizontal or slanted. The second inequality is a greater than. Notice that it does not have the equal bar. So again, this is a dotted line. That means any points on that line are not included in our answer. And you're going to shade to the right if your line is vertical, or up if your line is horizontal or slanted. The next inequality is the less than or equal to symbol. For that one, you would have a solid line because you do have the bar at the bottom. So whenever you have the bar, you're going to have a solid line. And you would shade to the left or down, just like you do for the less than. Left if your line is vertical, or down if it's horizontal and slanted. The last one is a greater than or equal to symbol, and this will be a solid again because it has the bar at the bottom. And you will shade to the right if your line is vertical, or up if your line is horizontal or slanted. Now, remember, these inequalities and these directions only work if your y is on the left side. So you would need to see your y on this side of the inequality, and the rest of the equation is on the right side. Let's look at the first explore example because they only did one line. So if you take a look here, and you can see that this equation is in the ax plus by equals c form, which means that you can use intercepts to solve. So your x-intercept is going to equal to 3 divided by 1. So if you do 3 divided by 1, it equals 3. This is your x-intercept. So that's this one here. For the y-intercept, you're going to take a look at the 3 divided by 3. So 3 divided by 3 gives you 1. So that is where they got the 1 from. Now that creates a boundary line. Now if you take a look at this problem, okay, and you see that this is a greater than, so we have a greater than, and from the previous slide we talked about greater thans. They're going to be dotted lines, and we are going to shade up. So this will shade up or to the right, but since we don't have a horizontal line, we're going to have a y-intercept at 1 and an x-intercept at 3. When you connect those two, and you can see them here, the y-intercept at 1, the x-intercept at 3. When you connect those two, you create a boundary line that is a dotted line. That's this dotted line here. And we are going to shade up. Now, if I were to shade down, this is shading up. So I'm going to put some up arrows here. Okay, because that's the direction in which we're shading. If I were to shade down, I would have been shading down here. But since this is a greater than, I'm going to be shading up. Now, there is one other important thing that you should look at. Had this number in front of the y been a negative, I would have had to switch the direction of this inequality. Since this is a positive, I'm going to keep the inequality in the same direction. And I'll say that again, if this number would have been a negative, I would have had to switch this to a less than. And if this would have been a less than, then I wouldn't be shading up, I would have been shading down. So that's something to look at. You always have to check the y to see if it's not a negative number. Okay, let's go try another problem. Okay, I'm going to work on letter B for you for the first example. Okay, you can see here that the 3x was moved to the other side, and what happens when we move a number to the other side, it becomes the opposite sign. Since 3 is positive on the left side, when I move it, it's going to become a negative. And you can see here where now the y is alone. It's still less than or equal to. The 3 became a negative 3x, and the 1 was already on that side as a positive 1. So now you have solved for the inequality for y. That's what this said here. Solve the first inequality for y. Now the second inequality already has y alone. If I would have had a negative here, though, the inequality would have switched directions. So we now have a system. So our first part of our system is y is less than or equal to negative 3x plus 1. The second inequality is y is greater than 2/3 x minus 2. Now remember that when we graph, this is our y-intercept, this is our slope, which is negative 3/1. And we're going to have a solid line because we have the bar. And since this is a less than, we're going to graph down. So let's go start there. So we're going to go to the y-axis at 1, which is this point here. From there, we're going to move down 3 and right 1 because the bottom number is a 1, negative 3/1. So we're going to go down 1, 2, 3, and right 1. So that would become this point here. When we connect those 2 points, the inequality is a solid line. So here's our solid line. And then we discussed about how this was a less than. So we're going to shade down. So this one shades down. Now, when we shade down, I like to put arrows before I graph, before I shade in. I just like to put arrows. It just makes it easier to see where the graph is going. So I'm going to make them here in blue. So these 2 are going down. I usually like putting 2 of them. Okay, and then now we're going to graph our second line. So we're going to start at the y-axis at negative 2. So here's your y-axis, and here is negative 2. I'll put a dot. Okay, I put a dot right there at negative 2. Now the slope is 2/3. That means I'm going to go up 2 and right 3. So if we go up 2 and right 1, 2, 3, that's this point on the x-axis. I'm going to put a dot there. Since this inequality does not have the equals, the bar at the bottom, this is going to be a dotted line. So when I connect these, it becomes a dotted line, and you can see the dotted there at the edge. So once these 2 are connected, it becomes a dotted line. And since this is a greater than, that means I will be shading up. So this one shades up. So now I'm going to be putting the dots, the arrows for that one going upwards. One for this one and one for this side. The next thing you need to look at is when two lines intersect, there are 4 areas that are created. I'm going to write those 4 areas in green with letters. So there's area A, there's area B here, there's area C here, and there's area D over here on the end. Okay, so you can see here that the 2 lines intersected, created 4 regions, A, B, C, and D. Now I'm looking for the region where I have both arrows coming into that region. So if you could see area A, I only have one arrow coming in. That's why I like using the arrows before I shade. Here, there is no arrow coming in. For B, you can see that both of the arrows are coming into area B. This is the darkest shaded area, so this is actually where your solution is. So B is the solution, that whole region. For C, you can see that I only have one arrow coming in, but I don't have one coming in from the other side. And for D, you can see that there are no arrows in this section. So that's why I like using the arrows. Now I'm actually going to use green to shade it in a little darker. So this area here is your solution. And even though we have shading here, that's not part of our solution. And even though we have shading here, that's also not part of our solution. Neither is this line, neither is this dotted line. And even along this dotted line here, along this edge, none of those points would be our solution. The only solution is along this solid line and this shaded area, this shaded region, and not along the dotted line. And again, C is not an answer, D is not an answer, neither is A. So I hope that helped for this. Now, the rest of the problem is asking for possible answers. So possible answers in this problem are 0, 0. 0, 0 is right here, and it is in the shaded region. -8, 0. If I go all the way to -8 and then do not go up or down, that's going to be in my shaded region. 0, and then the following two are not solutions. So if I go 0 along the x and y, along the x-axis, but go down -8, you can see that that's in the area of C. C is not a solution. And then if I go over to 4, 4, if I move over to 4, 4, that's in the A region, and A is also not a solution because only B is the region that's the solution. So these 2 points are solutions, and the second 2 points are not solutions. Okay, I'm going to go over B in example 2 and your turn in example 2 as well. Okay, so if you look at this first boundary line, it starts at -2, so that's here on the -2, and then it goes up 1, right 1. So this is this dotted line here, and as you could tell, it was shading up because it's greater than, so it shades up. So this shades up and is dotted. So now the arrows go up. Let me make those in blue so that you can see those a little darker. So these arrows go up. I'll make a few of them. Okay, for the second line, it starts up at 4, so it's here 4, and then we go up 1, right 1, so because there's a 1 here in front of the x, so up 1, right 1, so that's obviously going to be this solid line. It's solid because you have the bar at the bottom, so this is a solid line. But this is a less than, so the arrows for that one there, I'll make them in like a dark orange maybe. Okay, those are going to go down, so those arrows go down. Okay, so the region that's our answer is where the arrows are crashing into each other, so that's only this shaded area in the middle between the lines. That's actually our solution. So you can see there's shading here, but that's not the solution. You can see there's shading here, and that's not the solution. The only reason you're seeing shaded on the ends is because this line is sending a shade all the way down, and then the dotted line here is sending shade all the way up. But the only place where they're crashing is in the middle. That's the only place where both of them are sending shading. So the solutions are all the points between the parallel lines and that are on the solid line. So only along this line. This bottom line is a dotted line, so no points along the dotted line will be a solution. Let's go talk about number 6. Number 6 is very similar to B, but we have a -6, so, and then it goes up 1, right 3. So this is a dotted line because it does not have the bar. So this is this dotted line. Our arrows are going to shade down since this is a less than. So our arrows are going to shade down. So we're going to shade this way. Okay, sending the arrow this way. And then for the second line, obviously it's the other line. So you can see that it has a solid line because of the line. Solid line. And it's greater than, so it shades up. So that means our arrows are going upward. And since the shading goes up here, the shading goes down here, these two arrows are never going to crash into each other. So this system actually has no solution, because the solution to an inequality is where the shadings cross into each other. And since these are never going to cross into each other, there is no solution. You will never have points that are on both shadings at the same time. Okay, on this page, I'm actually going to help you with only this equation, probably because it has fractions, and I know you're going to have trouble with it, but you really shouldn't be having trouble with those fractions anymore. So you have 2/3 plus 1/3 y is greater than or equal to x. In order to solve for y, we are going to, let me just recopy it. Okay, so the first thing we're going to do is we're going to move the 2/3 over to the other side. Even though it's a fraction, it's okay, you can move it. So we're going to end up with 1/3 y is greater than or equal to x minus, now why did it turn into a minus? When we move a number to the opposite side, it changes signs. So it'll be minus 2/3. Now the next thing you want to do, I'm going to recopy again just because I want you to see the original. Okay, so now what we're going to do is we're going to take the denominator, which is 3 here and 3 here, and we're going to multiply our entire equation by 3. So when I multiply, 3 times 1 is 3, divided by 3 is 1, cancels out. I get equals to y. For our first one, the greater than or equal stays. Now I'm going to multiply 3 times x, and 3 times x is 3x. And now I'm going to multiply 3 times 2, which is 6, and 6 divided by 3 is 2. So I'm going to have a minus 2. So I'm going to match that with, match this equation, this inequality, with one of the ones that I have here. And actually I just want the boundary line, so I want the equation that goes along with it. Instead of an inequality, I should use an equal sign because it's going to be my boundary line. So y equals 3x minus 2. So that's exactly what I'm looking for. Y equals 3x minus 2 is E. So the answer to this problem is E. Now you have to do the rest of them. Okay, on this page, I'm going to do number 2 and number 4 for you. So on number 2, our job is to find out if this point, this given point, which is 0, 0, satisfies both of the inequalities. So I need to substitute for x equals 0 and y equals 0 for both. So if this was 0 and that was 0, then I would have 0. So 0 less than 6, that's my first one. And it's really what it is a question mark. Is 0 less than 6? And that is a yes. So it satisfies the first equation. Now for the second equation, this would be 0 and that would be 0, because 0 times anything is 0. So I would have 0 is greater than or equal to 0 minus 10. Now 0 minus 10 turns into 0 is greater than or equal to negative 10. So is 0 greater than or equal to negative 10? You can look at the number line, and 0 is here and negative 10 is on this side. So is 0 greater than negative 10? If it's to the right, then 0 is definitely greater than negative 10, because if we were to look at the number line, here's the number 2, and the number 2 is to the right of 0, so 2 is greater than 0, and 0 is greater than negative 10. So the answer to the second equation is a yes, the second inequality. That's a yes. So then that means that the answer to this problem is yes, 0, 0 satisfies the system. Satisfies the system. Okay, there's your answer to number 2. Now for our next problem, which is number 4, determine if the given point is a solution to the system of inequalities. If not, find a point that is. So the solution to the system is here. This is the darker shaded, okay? And so we're trying to find out if negative 9 comma 4 would be here. Now let me switch colors so that you could see this a little bit better. So negative 9 is here for the x, and positive 4 is here for the x. So our point meets here, negative 9 comma 4. So our point is in the shaded region. So the answer is yes, negative 9 comma 4 is a solution to the system. And pretty much that's all. Now remember, when you are taking a test, you should show work. This is work, okay? You're looking and you're drawing and you're checking to see if that would be a solution. You don't just say yes either. Yes is not the answer. The entire answer is you answer in a full sentence. You should always show all of your work. I am going to work on number 12 and number 14 with you. So on number 12, we have a y-intercept of 6. So 2, 4, 6. I'm going to put a point there. There we go. Right there. Okay, our point is now on the graph. Now our slope is 2. So our slope is really 2 over 1, which means I need to go up 2 and right 1. So from there, I am going to go up 2 and right 1, which is halfway. So I'm going to put a point here. The next step would be to check if it's a solid. Now, so if you can look to see if it has a bar at the bottom. If it has a bar at the bottom, then that means that our graph is solid. So I am going to graph a solid line to connect those two. Okay, and there you go. There's your line. It's solid. Now the next part of the problem would be for you to check if you're going to shade up or down. This is a greater than. Greater than is more than. So if you're looking at your graph here, here's the line. Which way is more than? Up or down? Obviously down is less than and up is more than, so I need to shade up. So I'm going to draw myself some arrows here just to remind myself for later that we will be shading upwards. Okay, now I need to graph the second line. Our second line starts at -1 on the y-axis. -1 is here. I'm going to put a dot there. Okay, and then our slope is -1 over 2. Since I have a negative, I can use it on top or on the bottom. So my slope for this problem is -1 over 2, which would send me down 1, right 2. Or I could use 1 over -2, which would make me go up 1 and left 2. So I could do both. I'm going to do both just so that I could show you. Okay, if I use the first one, I'm going to go down 1 and right 2. I should put a dot there. Okay, which I did. Now, if I use the second type where I move the negative to the bottom but not on the top, you can't have a negative on both or else you won't have a negative slope anymore. So you can only use the negative one time. So I'm choosing to use it at the bottom now. So that means I'm going to go up from my original point just 1, and then I'm going to go left 2. So here's my original point. I'm going to go up 1, left 2. So I'm going to put a dot there. So now I have 3 points, and I'm going to connect those 3 points with a line. And since this is a less than, but not a less than or equal to, this is a dotted line. So I need to make a dotted line, which I will. And I'm going to connect them. Okay, so you can see that I have put in a dotted line and I put an arrow at the end. Make sure you put an arrow on both ends because this is a line. And you should do that for the other line as well. Put arrows on the ends. That way to show that it's a line. Now the last thing I need is for me to put the arrows of which way I'm going to shade. So since this is a less than, I'm going to shade down. So here's my dotted line. Less than would be down and greater than would be up. So I need to shade down since this is a less than. So I'm going to put arrows going down in purple, just like my other one. So I'm going to shade down, and I'm going to shade down. Now remember, there were sections that were created with the 2 lines, the blue line and the purple dotted line. There were sections. In this section, in this region, I don't have any arrows for shading. In this region, which is above, I have blue arrow for shading, but not purple. In this region here, I have both. I have the purple and I have the blue, which this is my answer, and I'll shade right now in a second. And in the last region here, I have purple going into that section, but not the blue. So remember, you need to have both colors going in. So I'm going to switch to green so I can show you where the solution is. So the shading solution is in this region here. Okay, there's your answer. I'm also going to do number 14 for you since these lines look a little strange. So if you are looking at them, x is equal to -6 and y is equal to 3 are your boundary lines. Okay, now remember, if you have an x line, the x-axis moves left and right, but this graph is not going to get graphed this way left and right. We're actually going to graph this as a vertical line. So you're going to see this being graphed in purple as a vertical line. We're going to go up and down for this line. For the second line, I'm going to graph it in blue. So you can see that this line has a y-axis. It's a y-axis line, but the y-axis moves up and down. This line is not vertical. Y-axis, y equals lines actually graph horizontally. So you're going to see me graphing this one right and left on the number 3. So I'm ready to graph now because they're basically horizontal and vertical lines. There's nothing else you need to do for this. Okay, it's not like the top equations where you had the y-intercept and you had a slope. These are much easier to graph. The x lines go up and down, the y lines go horizontal, and pretty much that's all there is to it, except for the fact that you have to look to see if it's solid or dotted and whether it's shading up or down or right or left. Okay, so we're going to look at our first line. Our first line is a solid line. So we're going to go switch to the purple. Okay, so This first line is solid, and it's gonna shade. Since it's horizontal like this, we need to figure out if it's gonna shade to the left or to the right, and since it's greater, that's gonna shade to the right. So we are going to shade to the right, and I'm gonna write that down, to the right. Okay, so I'm ready to graph that one. Here is -6, so 0, 2, 4, and -6. So my line's going to go up and down here, and I'm going to shade to the right. So I'm ready to put in my line. Okay, I put in my line, and I'm going to put arrows pointing to the right, and I'm going to put my arrows at the end of the line to show that it's a line. And I put my arrows so that I could see where I'm shading, but I'm not going to shade yet because it becomes very messy if I start shading all these colors in. So let's go with blue now, the darker blue, and that one is a y equals line. So I'm going to go and put my y equals line. I'm going to find my y equals 3. So this is 0, 1, 2, 3. The y equals 3 line is going to go horizontally right at 3. Let me go graph that. So you can see how all y equals lines are horizontal, and I'm taking my line and moving it up 1, 2, and 3. So you can see how I moved it. Now I'm going to put my arrows in at the ends of the line, and I'm going to take a look if this is going to be a solid or a dotted line. So when I look at this here, this is a less than, so that solid line will not work for me. So I need to actually write this as a dotted line. So I'm going to go ahead and write it in as a dotted line. So my dotted line is going to go here, and I'm going to put arrows at the end. I still need to put in my shading. Since this is a less than and my line is horizontal, I need to figure out if I'm going up or down. Now, up is more than the line, and down is less than the line. So that means I'm going to shade less than, which is down. I need to shade down. So let me put arrows just to remind myself where I'm shading. Down and down. Okay, I'm going to go look at the 4 different regions now. So if we look at this region, I have purple arrow but no blue. If I look at this region, I have no arrows at all. If I look at this region down here, I have blue but no purple. And when I look at the bottom region, I have both. I have purple arrow and I have blue arrow. So now you can see why I use the arrows to help me with the different regions. Okay, so I am going to shade that in green for you so that you can see where the solution is. So all of the shading happens in this area here. And this is not the solution, this is not the solution, neither is this. My only solutions are in this green area, and of course not on the dotted line, and yes on the solid line. The solid line is solution, the dotted is not, and all the green is solution. So pretty much that's all there is to it. Okay, on this page I'm going to talk to you about number 18 and number 20. You can see right away from these inequalities that the slopes are the same and the y-intercepts are different. Right away that tells you that these two boundary lines are going to be parallel. How do I know that? Because the slopes are the same and the y-intercepts are different from each other. If the slopes would have been the same and the y-intercepts would have been the same number with the same sign, then I would have known that I have the same exact line twice. But since the slopes are different and the y-intercepts, since the slopes are the same and the y-intercepts are different from each other, these two boundary lines are going to be parallel. Same thing with number 20. You can tell because the slopes are the same number, 9/4 and 9/4, and the y-intercepts are different from each other, -1 and -9. They're different. So I'm ready to graph, and now I just need to double check that I know what's going on with each one. Okay, so on number 1, the inequality is greater than or equal to. That tells me that I'm going to have a solid line and my graph is going to go up. For number 2, I look and I have a less than or equal to. That means I'm going to have another solid line because it's equal to, but this time I'm going to shade down. So those are basically my necessities. On number 20, I can tell that on number 1, my inequality is greater than or equal to. That means I'm going to have a solid. So when I look at this on number 1, I'm going to have a solid line. And since it's greater than, I know that I'm going to shade up. For number 2, since I have less than here, I know, and I don't have an equal, I know that this is going to be a dotted line. And because it's less than, I'm going to shade down. So I'm ready to graph both of my equations. Okay, so I have graphed my first line. Let me show you. Okay, I have a y-intercept at -3, down 1, 2, 3. And then I have a slope of -3, right 2. So from here I'm going to go down 1, 2, 3, and right 2. There you go. Also from here I could have gone up 1, 2, 3, and left 2. So that's how you know this is the right line and it's solid. And then I know that I'm supposed to be solid and I'm supposed to be shading up. So I'm going to put in arrows going up just for later shading. Okay, I'm going to switch colors to pink for the next inequality. For my pink line, I have a y-intercept of, and these lines should not be just put anywhere. So you can see that I have a y-intercept of 10, positive 10. And from there I go down 3, right 2. So 1, 2, 3, and right 2. Next, so I have a solid line. Now I need to put in my shading. So my shading is supposed to be going down. So I'm going to make sure that I put some arrows going down from that line. Down and down. Now I can see that when I have parallel lines, 3 sections have been created. This section that has no arrows, the middle section that has both pink and green arrows, and the bottom section that does not have any arrows also. So I'm going to shade in light blue for you where the solution is, where the both arrows are crossing each other, and both of my parallel lines were solid. So this would be the solution. This here would be the solution, and make sure that you don't get out of the parallel lines. You still show the shading, but don't go outside of the parallel lines. So there you go. That is where the solutions are found. For number 20, let's go look at that. I have put in the first line, which starts at -1. So here's 0, down 1. There's my point that intersects the y-axis. Now from there I'm supposed to go up 9, right 4. So we're going to go up 9, starting here, going up 1, 2, 3, 4, 5, 6, 7, 8, 9, and right 4. 1, 2, 3, 4. So the line ends up where I see this. You see where I have the line, so that point is obviously on the line. Now what if I decided to go down 9 and left 4? That means both of my signs change. The positive 9 turns into a negative, and the positive 4 turns into a negative also. because a negative over a negative will still be a positive, just like what I have here. But I can switch it around. So starting at my original point of -1, I'm going to go down 9 and left 4. Down 1, 2, 3, 4, 5, 6, 7, 8, and 9, and left 4. 1, 2, 3, 4. And you can see that where I landed is on the green line for both times. So my line is drawn correctly, and it is solid because it is a greater than or equal to. Now my shading is, since it's greater, it's going to go up. So I'm going to put a couple of up arrows for the later shading. Since my lines are parallel, I know my pink line is going to be parallel to this line, but this is going to be a dotted line. The reason it's going to be a dotted line is because this is a less than, only a less than, but not greater, not equal to. So it does not have the bar at the bottom, which is going to make it a dotted line. My y-intercept is 9, so I'm going to start my line at -9, which is right here. That's the point. And then I'm going to go up 9, right 4 from there. Okay, I have drawn my line, so you can see that I started at -9. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the y-axis, and then I went up 9, right 4 twice. So I went up 1, 2, 3, 4, 5, 6, 7, 8, 9, right 1, 2, 3, 4, and then I did it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and right 4, 1, 2, 3, 4. So you can see that I connected those 3 points using a dotted line, and now all I need is my shading. So according to my notes that I did earlier, I'm supposed to shade down. So let me put some arrows going down. Okay, now let's take a look at our regions. So if you take a look at this region, this has pink shading. This has no shading at all because there are no arrows in this section. And the top has green shading. So you can see here that in the pink shading and the green shading are never going to cross each other. So that means that for this problem there is no solution because they are never going to intersect. The rest of the problems are there for you to practice on your own now.